So I'm going to show you the steps needed to create a Lewis dot diagram for a single bond molecule. Okay, so we're going to draw the molecule carbon tetrachloride. Carbon is underlined because it's in the middle. There are 4 valence electrons in carbon, and there are 7 in each chlorine atom. So we have to first total up the valence electrons, which gives you 32 in total. Now we're going to draw the skeleton of the molecule with a single bond to each chlorine atom. It requires 2 electrons to make each bond for a total of 8. So I'm subtracting off 8 from my total. So now I have 24 valence electrons left. These 24 electrons I will use to complete the octet of every atom in the molecule, if possible. So I distributed 3 pairs on the first chlorine, which took up 6, 3 on the second, 6 more. Here, this chlorine needs 3 pairs. Remember, we distribute them in pairs. So now I have 6 left for the last chlorine. And that uses up all of my valence electrons. And now I'm going to double check, count to see that each atom has 8 electrons. Remember, the single bond counts as 2 to both atoms that it's bonded to. And then the other check is to count to make sure I have 32 valence electrons in my structure in total. If both of those check out, then you're done. And voila. Here's another example of a Lewis dot structure. Sulfur difluoride. S is in the middle. S has 6 valence electrons. Each F has 7 for a grand total of 20 valence electrons. So now we're going to do the skeleton of the molecule. We're going to draw a single bond to each F. That takes up 4 electrons, 2 for each bond. So now we have 16 left. Now I'm going to distribute those 16 in pairs to give everyone an octet. So there's 6 for the first fluorine. I have 12 left. Oops, math error. I have 10 left. I'm going to distribute 6 to the other fluorine in pairs. So I have 4 left, just enough for the sulfur. Now I'm going to double check and make sure everything has 8. Yep. Now I'm going to check and make sure I have 20 valence. 20 altogether. Check. And it's complete. One more example with single bonds. This is a classic. Ammonia, which is NH3. Nitrogen is in the middle. 5 valence electrons for each nitrogen. 1 valence electron for each hydrogen. So for a total of 8 valence electrons. There's my N in the middle, and I'm going to draw my skeleton of the structure. 1 single bond to each hydrogen. Subtract off 6, that leaves me with 2. And nitrogen is the only one who needs more electrons, so it's checked. That's easy. Hydrogen is an exception. It only gets 1 single bond. It does not get any valence electrons or electron pairs. So this structure is complete with 1 pair of electrons on the nitrogen and 3 single bonds.